So now we will look into uh, a concept called how can we integrate a configuration tool with Docker, like likes of Chef with Docker, likes of Ansible with Docker. That's what we are going to explore at this moment. So building images with Chef Solo. So one of the things that confuses newcomers to Docker is whether Docker files are the only supported configuration management tool and whether the existing configuration management tools should ported to Docker files. Neither of these is true. So, although Docker files are designed to be a simple and portable means of provisioning images, they are also flexible enough to allow any other configuration management tool to take over. In, in, in short, if you can run it in a terminal, you can run it in a Docker file. That's it. If you can run it in a terminal, you can also run it in a Docker file. As a demonstration of this, we will show you how to get up and running with Chef. So arguably the most established configuration management tool. Arguably, not actually. So in a Docker file, using a tool like Chef can reduce the amount of work required for you to configure images. Problem statement for us here is you want to reduce a configuration effort by using Chef. So solution for that, we will install Chef in our container and run recipes to provision it, and if we have a lot of recipes, then it will become a playbook or cookbook. As it is a chef, it's a cookbook. If it is Ansible, it's a playbook. So in this example, we are gonna provision a simple hello world Apache website using Chef. So this will give you a taste of what Chef can do for your configuration. For this example, we are using Chef Solo, which requires no external Chef server setup if you are already familiar with Chef. So this example can easily be adapted for your pre-existing scripts. So I'm gonna walk through the creation of this Chef example, but if you want to download the working code, you just visit the Git repository that I will provide the link in comment section. Okay. So we will begin with the simple aim of setting up a web server with Apache that outputs hello world when you hit it, when you run it. So the site is going to be served from mysite.com, and a mysite user will be set up of the image. So to begin, let's create a directory and set it up with the files you will need for Chef configuration. So this is how mkdir chef example, then cd, then touch attributes.json, and you provide all the information. Then you write a touch docker file, and let's go. Let's go through each of the activity in this. So we have touch attributes.json. So we have to write this file, the chef attributes file, which defines the variables for this image or node in chef parlance, will contain the recipes in the run list for this image and other information. Then we have touch config.rb. So the chef config file which sets some base variables for the chef configuration. Then we have a Docker file, the Docker file that will build the image, and we have a cookbook with recipes. So this create the default recipe folder which stores the chef instructions for building the image, and finally we have the cookbooks with a default templates. It creates the templates for the dynamically configured content. So default attributes.json file looks like this, a run list, and inside that you have to provide the required recipes such as Apache 2 default, my site default. So let's continue with building images with Chef Solo. So the files that we have created, that sets out the recipes that you are going to run, and the two Apache 2 recipes will be retrieved from a public repository that link I'm going to provide. So, and as we have seen attributes.json file. So similarly it looks like that. So this file, the attribute.json file, sets up basic information about the location and adds the configuration security configuration setting and verify API certificate to suppress an irrelevant error. So let's go through the complete file. Here it is. So creates a my site user, then it's sent. After creating a user, let's create a directory for the web content. So that's what the directory, user, and then directory, and then template defines a file that will be placed inside the web folder. This file will be created from a template defined in the source attribute. Once this is done, then web app, define a web app for Apache 2, and all the placement and location into the hosting directory is also being done. And then so in a real scenario, you would have to change these references from my site to your website based on if you use your web applications, you have to change. The rest all remains same. So finally, you put everything together with the Docker file, which sets up the Chef prerequisites and runs Chef to configure the images as shown in this listing. That's it. Our image is ready. Sorry. Our Docker file is ready on right side. You can see that from Ubuntu, run apt-get update and apt-get install git curl. Then you have to fetch the repository. Then you have the copy the Chef. We have Chef Solo already been installed in our server, and remaining will go as it is based on the config files. Then you do Docker build and name of the image is Chef example. Then you do the Docker run TIP port mapping with 8080 to 80 of the 8080 of the host to the 80 of the container, and name of the image is Chef example. That's it. Once it is done, you should be able to see. If you navigate to this HTTP and then public IP of the instance and then port number 8080, you should see your hello world message. So although this is a trivial example, the benefits of using this approach should be clear with a relatively straightforward configuration files. The details of getting the image into a desired state are taken care by the configuration management tool. This doesn't mean that you can forget about the details of configuration. Changing the values will require you to understand the semantics to ensure you don't break anything. But this approach can save you much time and effort, particularly in projects where you don't need to get into the details too much. So with this, we have reached to the end of the first video of Docker part, that is Docker containerization. In this, we have covered lot of topics and we have done lot of examples, lot of exercises. I hope you enjoyed each and everything. Let me sum up everything. We have begun with life before Docker and life with Docker. Then we have moved to the history of the Docker. Then we have seen the complete comparison, how the three times of effort life before Docker has become one time effort life with Docker. Then we have seen the advantages. Then we have seen the benefits of Docker image, using a Docker image, how you can build a lot of containers from single Docker image, and that's what we have seen. And after that, we started writing our own Docker file, and we started building our own Docker images, and we started pushing our Docker images into the Docker Hub, and we started using those pushed Docker images again and spin containers. So this is what we have done. After that, we entered inside the engine room and we have explored each and every component of Docker and Docker engine. Then we have completely understood the Docker architecture, Docker engine architecture, and how it connects with each other. And example, Unix domain socket and HTTP request response and Docker client, Docker daemon, and docker.sock. So everything we have seen with a lot of examples. And finally, we came to day-to-day Docker, where we have discussed about the data persistence, volume mount, bind mount, and even data container and NFS. A lot with examples. Everything is with examples. Then finally we move to configuration management. There we have seen the difference between entry point and command, and we also looked into the reverse engineering of the Docker file and Docker image, reverse engineering of the Docker image, and finally we also seen the difference between a kill and stop, and we have done enough of housekeeping. I hope you enjoyed it, because this is very important tool nowadays, irrespective of you're a data scientist or a DevOps engineer or software engineer or an ML engineer. Irrespective of your designation, Docker is the minimum requirements. I've seen in plenty of job descriptions. It's a bare minimum requirement these days. That's why I have given a lot of examples, so that you can easily learn it. Okay, if you want anything, if you want the files that I've used in this example, you just ping me on comment section. I will provide you complete GitHub repository from where you can get each and every file that I have used in these examples. I hope you enjoyed it. If you enjoy it, keep liking it, keep subscribing it, keep spreading it, keep telling everybody, so that everybody can get benefit out of it. And until then, bye bye, see you. Keep loving me, keep liking me, keep subscribing. Thank you.